Viewers, it's Crystal here. In this particular video, what we're going to be talking about is bias in sampling. So in a previous video I talked about the different sampling techniques that can be used to sample data. And so, but one thing that can come up when you're sampling data is you can also have bias. And bias is not necessarily something that you want when you're conducting your research. So bias in sampling means that a sample is systematically different from the population being studied. Bias happens when some members of the population are more likely to be included in the sample than others, not by random chance, but by the way the sample was chosen. So an example of bias in sampling is, let's say that you want to do some research and find out what students in a university think about food on campus. So if the only people that you survey are the people who are actually eating in the cafeteria on campus, then you're going to have a biased outcome. And the reason why is because you're only sampling that proportion of the population that eats at the cafeteria, and you're not sampling the portion of the population that doesn't eat in the cafeteria. So that is an example of bias in sampling. So what we're going to do is we're going to conduct an experiment in R to show you how you can create bias in sampling in the R programming language. So the first thing you want to do is you want to create your population. So population becomes R norm, and that's a normal distribution randomly sampled, brackets 10,000, that's 10,000 samples, comma, mean equals 50, comma, SD, that's standard deviation, equals 10. And then we're going to calculate the true population of the mean. So true mean becomes mean of the population. And then you're going to have 2 is an unbiased sample. So this is a simple random sample. So sample unbiased becomes sample, brackets, population, comma, size equals 200, comma, replace equals false. So the size means that you're going to sample this population 200 times, whereas the size of the population is 10,000. And it's going to be without replacement. So when you take the sample, you don't replace it. And then we're going to have a bias sample, and we're only going to choose the values below 50. So bias pool becomes population, square brackets, population less than 50. So you're only going to take the samples less than 50. And so that's going to be a little bit difficult anyway, because on the unbiased sample, the size of the sample is 200. And on the biased sample, it's going to be less than 50, so it's only going to be 200. It's only going to be 50 and not 200. And so sample bias becomes sample brackets, biased pool, that's your population, that's going to be 1 to 50, comma, size equals 200. So the size is going to be 200 samples, comma, replace equals false. So you're not going to replace it. So that's going to be a bit unusual to work with since you're sampling without replacement. And if the population is below 50, then it's going to be 1 to 50. But let's go ahead and carry on with this experiment. So mean unbiased becomes mean brackets sample unbiased. So that's the mean of your unbiased sample. And mean bias becomes mean brackets sample bias. So that means it's the mean of the bias sample. So your true population, you're going to print off your true population, which should be around 10,000. And you're going to print off your unbiased sample mean, and we're going to print off the biased sample mean. And then, so your true population is 49.97. That's your mean of that. Your unbiased sample mean is 49.84941, and your biased sample mean is 41.25451. Because you can see that the unbiased sample mean takes 200 samples. See what it takes. It takes 200 samples, the size of a population, and then without replacement. And then the biased sample, it says 200 samples of the biased pool without replacement. So your sample of your population is a normal distribution, has a mean of 50. And then the biased pool is everything below 50. So 50 is going to be your maximum. So right there, your mean is 50 for your unbiased sample, and your mean is 41 for your biased sample, because all of these samples are without replacement. So we're going to create a histogram of what we have calculated. So hist brackets population, that's going to be 10,000, comma, breaks equals 30, comma, color equals gray 80, comma, main, and that's your label, equals population versus unbiased versus biased samples. XLab, that's your label. On your x-axis is value. Then we're going to put 3 lines in there. One line is going to be your true mean, which is blue. The second line is going to be your unbiased mean, which is dark green. And the third line is going to be your biased mean, which is red. And then on the legend, it's going to be top right. So your legend is going to be a true mean, unbiased sample mean, and biased sample mean. The color is going to be blue, dark green, and red. And we're going to look at the histogram that we have created. So population versus unbiased versus biased samples. So this is the histogram we have created. So your biased sample is 41, and your true mean is 49 or 50, and your unbiased mean is 49. So, or really, true mean is 49.976. Unbiased sample mean is 49.849, and biased sample mean is 41.254. And the reason for that is because the biased sample mean is only taking a sample up to 50, and then anything above 50, it doesn't take it. And then your unbiased sample takes everything. So we've got a normal distribution from 0 to 100, and 20, it's basically 20 to 80. And so your mean and your unbiased sample mean are pretty much the same, really close together. And your biased sample mean is really low. And that's because the unbiased sample mean takes a sample from 0 to 100, whereas the biased sample mean takes a sample from 0 to 50. And then so we can go ahead and reinforce that by looking at your population is a randomly selected normal distribution of 10,000 values with a mean of 50 and a standard deviation of 10. Your unbiased sample mean is a sample of the population, and it's going to take 200 samples, and replacement is false, so it's not going to replace that. And your biased sample mean is a sample of the biased pool, which is everything below 50, with 200 samples, and the replacement is going to be false as well. So this is how we have discussed bias in sampling, and obviously that's something that you're going to need to be made aware of when you conduct your research, because you have to make sure that your research is unbiased, because if your research is biased, then you're not going to get a correct outcome. So that concludes this video. The next video is going to be on another topic of statistics and probability, and I hope you decide to watch it.